Okay, so in this video I'm going to have a look at rationalizing the denominator of fractions. So first of all, let's just look at what an irrational number is and what a rational number is. A rational number is basically a number that can be expressed as a fraction, or formally it can be expressed as something like a over b, for example, is a fraction, where a and b are integers. So they're numbers like -3, -2, -1, 0, 1, 2, 3, and they go on forever in both directions. But b cannot be equal to 0. You can't divide by 0. You can't have a b or a denominator as 0. So any number that can be expressed as a fraction is a rational number. Now, when we have a fraction, like for example, I'm going to do a few examples, but let's say we start with this one here. Let's say we start with 1 over the square root of 3. Now, the square root of 3 is an irrational number. It's the square root of a prime number. Prime numbers, remember, are numbers that start with 2 and then 3, 5, 7, 11, and so on. These are numbers that only have two factors themselves, the number themselves, and 1. In this case, 3 is a prime number. The square root of 3 then is called an irrational number. You can't express the square root of 3 as fraction. So let's see if we can rationalize the denominator. The denominator currently is irrational, so we want to try and change the denominator to a rational number, to a number that we can express as a fraction. So what we're going to do is we're going to take what's on the bottom here, the square root of 3, and we're going to multiply the top and the bottom of the fraction by the square root of 3. So this number here is effectively 1. Anything divided by itself is 1. So what we're doing is we're taking this fraction here and we're multiplying it by 1, which doesn't change the fraction itself. So if we do that, what actually happens then? Well, what happens is to multiply fractions, you multiply the top by the top and the bottom by the bottom. So if we multiply 1 by the square root of 3, we get the square root of 3. If we multiply the square root of 3 by the square root of 3, we will get 3. In other words, the square root of 3 multiplied by itself is just the square root of 3 squared. So this square will, if you like, cancel out that square root symbol and we just end up with 3. Or if you think about it, the square root of 9 times the square root of 9 is, well, the square root of 9 is just 3. Multiply that by the square root of 9, which is 3, and we just get 9. So the square root of 9 times square root of 9 is just 9. So what we've effectively done here is we haven't changed this fraction, we've just changed the way it looks. We've multiplied the top and the bottom by the same number, or we've multiplied the entire fraction by 1, so we haven't changed it. And look what's happened, we've ended up with a 3 on the bottom. A 3 is our new denominator, and that is a rational number. 3 can be expressed as a fraction, just 3 over 1. So the top and the bottom, the numerator and the denominator, are both integers, and the denominator is not 0. So that's my first example of what you would do to rationalize the denominator. Let's try another one. So this is example 2. And let's take 2, let's do this in white. So it's 2 over 1 plus the square root of 5. So in this case, what we're going to do is we're going to multiply the top and the bottom by what's called the conjugate of this number here. The conjugate just means that you take the sign in the middle and you're going to change that to a minus. So it's 1 minus the square root of 5 over 1 minus the square root of 5. So again here, we're just multiplying our fraction by 1. Anything divided by itself here will just give us 1. So we're multiplying this fraction by 1. And we're multiplying it by this version of 1, if you like. So why are we doing this? Well, let's just do it and see what happens. We need to multiply this fraction by this fraction, so we're multiplying the top by the top and the bottom by the bottom. So really what we have here is 2 times 1 minus the square root of 5 divided by 1 plus the square root of 5 times 1 minus the square root of 5. So let's multiply out the top and the bottom. Well, to multiply out the top, you just multiply 2 by 1 and 2 by minus root 5. So let's do that. So 2 times 1 is 2, plus times minus minus, and 2 times root 5, well, it's just 2 times root 5. On the bottom then, we need to multiply out these two brackets. Now the way you're going to do this is you need to multiply 1 by 1 and 1 by minus root 5. And then you multiply plus root 5 by 1 and then plus root 5 by minus root 5. So you multiply everything in the first bracket by everything in the second bracket. Now if you like, you can write it out like this. Take this 1 here, multiply that by the second bracket, which is 1 minus the square root of 5. Take the plus root 5 and multiply that by the second bracket, which is 1 minus root 5. So what you end up with on the top is just 2 minus 2 root 5. On the bottom then, let's multiply out these brackets. 1 times 1, 1. Plus times minus, minus. 1 times root 5 is root 5. Plus times plus, plus. 1 times root 5, root 5. Plus times minus, minus. Root 5 times root 5 is just 5. Okay, so now if we look at what's on the top, we've got 2 minus 2 root 5. On the bottom, we've got 1 minus 5, which is minus 4. And what we've got here is a minus root 5 plus root 5, which will just give us 0. Now you may have spotted here that on the top, we've got a common factor here and here of 2. So we can take 2 outside the bracket here. 2 times 1 will give me 2. 2 times minus root 5 will give me minus 2 root 5. So I've just factorized this using the common factor method. 2 times 1, 2. 2 times minus root 5, minus 2 root 5. On the bottom, I've got minus 4. So now I've got this 2 multiplied by this bracket. I've got minus 4 on the bottom. So what I can do here is divide this 2 into this minus 4 to give me minus 2 on the bottom. 2 into minus 4 is minus 2. So let's see what we end up with. On the top, 1 minus root 5 divided by minus 2. What I like to do, I don't like the fact that this is leading here on the bottom with a minus. So what I'm going to do here is just multiply the top and the bottom. I'm going to multiply the top and the bottom by minus 1 over minus 1. So again, I'm just multiplying by 1. Anything divided by itself is just 1. So this is just another version of 1 if you like. So the reason I'm going to do this is, you'll see when I do it, if I multiply all of this by minus 1, you multiply this by minus 1, it'll give me minus 1. Multiply this by minus 1, it'll give me plus root 5. So I've just switched them around as well, because I've got a leading plus here. If I multiply the bottom by minus 1, minus times minus is plus, 1 times 2, 2. So now I don't have this leading minus here on the bottom. I've got a plus here and a plus here, which is the way I like to see these kind of fractions. So now have I rationalized the denominator? Well, the denominator originally was way up here. Originally it was 1 plus root 5. The square root of 5 is an irrational number, so this entire denominator was irrational because the square root of 5 is the square root of a prime number, so all of this is an irrational number. So what have we changed it into? We've changed it into the square root of 5 minus 1 over 2. The denominator now is a rational number. You can express 2 as a fraction. It's just 2 over 1. So this is a rational number. Okay, it's still the same fraction that we started with. It just looks different. Okay, so let's go again then. Let's try another one. So this is example number 3. And this one is 3 minus the square root of 3 divided by 3 plus the square root of 3. Now you probably realize at this stage what we need to do. We need to take the denominator, which is an irrational number, because this square root of 3 here is irrational, so the square root of 3 plus 3 is going to be irrational. This is the square root of a prime number again. So what we're going to do here is going to multiply by the conjugate of this over itself. So we're going to multiply by 3 minus the square root of 3 over the 3 minus the square root of 3. So that's going to be equal to, again, it's fraction times a fraction. So what we do is multiply the top, which which is the square root of minus 3. Just going to put it in brackets. Multiply by the top, which is 3 minus the square root of 3. And then on the bottom, we've got 3 plus root 3 times 3 minus root 3. So on the top, again, what we're going to do is multiply out these two brackets. So I'm going to do it the long-winded way, if you like. So we're going to take the 3. I'm going to multiply that by the second bracket, which is 3 minus root 3. I'm going to take the minus square root 3, and I'm going to multiply that by the 3 minus root 3. Okay, on the bottom then I'm going to do the same thing. So if you've done factorizing before, you may recognize that this is actually the difference of two squares, which means it's actually 3 squared minus the square root of 3 squared, which will make it easier to do. This just becomes 9 and this becomes minus 3. So this will just become 6. So let's see, do we end up with a 6 down here? I'm going to do it a different way. So let's do that then. Okay, so what we're going to do is we're going to take the 3. We're going to multiply that by the second bracket, which is 3 minus the square root of 3. I'm going to take this plus root 3. I'm going to multiply that by the second bracket, which is 3 minus root 3. Let's have a look what we get when we multiply all these brackets out. So 3 times 3, 9. 3 times minus root 3, minus 3 root 3. This one here then is minus times plus, which is minus 3 root 3. And then we have minus times minus, which is plus. Root 3 times root 3 is just 3. On the bottom then, we've got 3 times 3, 9. Here we've got minus times plus, which is minus 3 root 3. Here we've got plus 3 root 3. And then here we got plus times minus, which is minus. Root 3 times root 3 is just 3. Okay, so we're almost there. Let's just finish this off then. So we have on the top, we have 9 plus 3, which is 12. We've got minus 3 root 3 minus 3 root 3, so that's minus 6 root 3's if you like. And then on the bottom, we've got minus 3 root 3 plus 3 root 3, so they cancel, or they just give us 0 if you like. And then on the bottom, we simply end up with 9 minus 3, which is 6. And that's what we did when we did it the difference of two squares method. You may spot here as well on the top that we can factorize this. We can take out a common factor. That common factor, happily enough, is 6, because we've got a 6 on the bottom as well, so that's going to be handy. So what do we multiply 6 by to give us 12? Well, it's just going to be 2. Minus, what do we multiply 6 by to give us 6? Well, just 1, so it's 1 times root 3. And then on the bottom, we've got 6. This here is multiplied by the bracket, so we can divide that by this here to give us finally 2. I'll just move this up a little bit. 2 minus the square root of 3, and it's really just over 1. So have we rationalized the denominator? Yes, we have. The denominator is 1. 1 can be written as a fraction, just 1 over 1. So our original denominator was an irrational number. We multiplied it by a version of 1, the conjugate of the denominator. We did a little bit of multiplying and manipulation, and we ended up with the same fraction. This is the same fraction that we started with, but we ended up with 1 as our denominator. So this is example number 4. And this looks like, let's see, square root of 2 minus the square root of 3. And then on the bottom, we've got the square root of 2 plus the square root of 3. So again, we just take the conjugate of this thing down on the bottom here. So it's going to be the square root of 2 minus the square root of 3 divided by the square root of 2 minus the square root of 3. Again, this is something divided by itself. So this is just 1, another version of 1. So we're multiplying this fraction by 1, so we're not changing it. We'll change the way it looks, but we're not actually changing the fraction. If you like, it's like, let's say, a half. Multiply a half by, let's say, 2 over 2. This is just 1. What do you get? You get 2 on the top. 2 times 1 is 2. 2 times 2 on the bottom is 4. So we've changed a half into 2 over 4. Both the same fractions. This is the simplified version. This is the non-reduced version, if you like. but they're still the same fraction. Okay, so let's multiply out these fractions. Let's multiply the top by the top and the bottom by the bottom again. So I'll just write them out in brackets first. So it's square root of 2 minus the square root of 3 times the square root of 2 minus the square root of 3. And then on the bottom, we've got the square root of 2 plus the square root of 3. And again, square root of 2 minus the square root of 3. So you can probably spot here that this is the difference of two squares again. So you can do it the other way if you like. So I'm going to take the square root of 2 and I'm going to multiply it by the second bracket. So it's the square root of 2 times the square root of 2 minus square root of 3. Now I'm going to take the minus root 3. I'm going to multiply that by the second bracket. Square root of 2 minus square root of 3. So now I'm going to do the same thing on the bottom. I'm going to take the square root of 2, multiply it by the second bracket. So we're going to take the square root of 2 times the square root of 2 minus square root of 3. And I'm going to take the plus root 3, multiply that by the second bracket. Square root of 2 minus square root of 3. So let's multiply all this out. So you multiply this by this, and this by this, this by this, and this by this. So let's do that. Square root of 2 times the square root of 2 is just 2. Plus times minus is minus. Square root of 2 times the square root of 3. I'm just going to write it down for the moment, and I'll go through what we need to do with that in a second. Now I'm going to do minus times plus, which is minus. Square root 3 times square root 2 is square root 3 times square root 2. Minus times minus is plus. And we've got square root of 3 times the square root of 3, which is just 3. Divided by. Now let's just multiply out the denominator. So we got square root of 2 times square root of 2 is 2, plus times minus minus, square root of 2 times square root of 3. Again, I'll just write that down for the moment. Here we've got plus times plus is plus, square root of 3 times square root of 2. Here we've got plus times minus minus, square root of 3 times square root of 3 is just 3. Okay, so on the top then we end up with 2 plus 3, which is 5. So here we've got the square root of 2 times the square root of 3. So what are we going to do with that? Well, what you can do with that is just write it as, if you like, the square root of 2 times 3. And over here, same thing. Square root of 3 times square root of 2, you can write it as the square root of 3 times 2. On the bottom, we can do the same thing. We've got a 2 and we've got a minus 3. That's minus 1. So what we can do now is just simply cancel these two here if you like. Why can we do that? Well, we've got a minus root 2 root 3 and we've got a plus root 2 root 3. So they just give us 0 if we add those two. So this is, we're almost there now. So we have on the top, we've got 5. And here we've got 2 times 3 and we've got 3 times 2. So we end up with minus root 6. And we've got minus root 6 here as well. So on the bottom, we've got minus 1. So on the top, we've got 5. We've got minus 1 root 6, minus 1 root 6. That's minus 2 root 6s. And on the bottom, we've got minus 1. So that's really it. But I'm just going to, again, get rid of this leading minus here by doing what we did in the previous example. I'm going to multiply the top and the bottom by minus 1. So again, I'm just multiplying our fraction by 1. This is just 1. Minus 1 divided by minus 1 is just 1. So if I do that, I will get, if I multiply this by minus 1, I'll get minus 5. If I multiply this by minus 1, I'll get plus 2 root 6. And again, I've just switched them around. On the bottom, multiply this by minus 1, I'll get plus 1. So now you can see this is our final answer here. We have a 1 as our denominator. Is it a rational number? Yes, it is. We can express that as 1 over 1 as a fraction. So we've rationalized the denominator. This is the same fraction that we started with. It just looks different, and we have now rationalized the denominator. Okay, so that's it for this video on rationalizing the denominator.